Hi friends, welcome back. Today we are going to solve another very recent and very popular Leetcode coding interview question 2542 maximum subsequence score. As you can see here from like dislike ratio, this is another very popular and likable medium complexity array coding question. So we are going to go through this problem today, understand the logic, how to solve this problem, as well as understand the Java solution code to solve this coding problem. If you haven't already subscribed to this channel, please subscribe to this channel now. Also click on the bell notification icon button right away so you won't miss any important postings from this channel. Here we create videos to help others in their interview preparation and learning different computer science concepts along with data structures, algorithms, problem solving, Java programming and coding. So let's start. You are given two zero indexed integer arrays num1 and nums2 of equal length n and a positive integer k. You must choose a subsequence of indices from nums1 of length k. For chosen indices i0, i1 to ik minus 1, your score is defined as follows. The sum of the selected elements from nums1 multiplied with minimum of the selected elements from nums2. It can be defined simply as nums1 i0 plus nums1 i1 plus nums1 ik minus 1 multiplied by minimum between nums2 i0, nums2 i1, nums2 ik minus 1. Okay, return the maximum possible score. A subsequence of indices of an array is a set of that can be derived from set 0, 1 to n minus 1 by deleting some or no elements. Okay, that is the definition of a subsequence. So we'll go through some examples. Constraint says that the nums1 dot length and nums2 dot length is n. N is between 1 to 10 raised to 5 inclusive. So maximum number of elements in the array will be 1 lakh, right? So arrays will be very long, and 0 is less than equal to nums1 I and nums2 j is less than equal to 10 raised to 5, and 1 is less than equal to k is less than equal to n, right? This is what the problem says. So let's take a look at this first example, right? So you know what subsequence means, right? So for the people who doesn't know, I'll quickly explain them. So let's say you have some array. Let's say you have array 1 2 3 4, right? This is your array, right? Now you want to take, let's say, subsequence k, let's say, is equal to 2. Subsequence of length 2 you want to take. So you can delete any two elements from this array basically, right? So I can delete 2 and 3 and 1 4 will be a subsequence, right? Or I can remove 3 and 4 and 1 2 will be a subsequence, right? Or I can remove 1 and 2, 3 4 can be a subsequence of the original array. Okay, but I cannot say that 4 and 4 1 cannot be a subsequence, right? Even if I delete 2 and 3, it will give me 1 4 as a subsequence, not 4 1. I cannot change the order of the elements. Okay, so this is a subsequence definition. Okay, so let's go back. So now this is one example over here. So nums1 has 4 elements, nums2 has a 4 elements, k is equal to 3. So we want to choose a subsequence of 3 elements so that we can get maximum score. So how we will define the score? The score will be the sum of the elements that we are choosing from nums1, correct? For example, let's take a look at this one. So they have shown us couple of examples, right? So they are saying that if you take 0 1 2, right, if you take this 0 1 2, then what is the sum? 7. 7 is your sum, right? And for this 0 1 2, what is the minimum number of element? 1. So 7 multiplied by 1 is your score. Okay, 7 multiplied by 1, which is 7, is your score. If you choose 0 2 and 3, right, so 0 is 1, 2 is 3 and 3 is 2, right, then your sum will be 6, correct? And if you take 2 here and 3 4, the minimum will be 2. So 6 multiplied by 2 is 12. That is your score. So that is the maximum possible score basically in all these scores. As you can see here, they have shown us all possible scores actually, right? So 7 6 12 and 8. So you want to find maximum. So 12 is the maximum score that you can get when you choose the indices 0 2 and 3, right? So here is another example. Here again you have four elements here, four elements here, right? Okay. Now let's take a look how we can get a maximum score here. So the maximum score can happen if I choose these three indices, right? If I choose these three indices from this array, and this is also same indices here, right? So this first thing will give me the sum. So I have to calculate sum of this one. So sum is 16 plus 14 is 30 plus 12 is 42, right? So 42 is my sum, right? And for this one, what is the minimum between 4, 6 and 8? 4 is the minimum between all these. Okay. So how they will define the score? 42 multiplied by 4 basically. That is how they define the score. So if you find this, then it will give you 168, right? 168. So this is your maximum score and this is your output, as you can see here, right? So this is the maximum you can get. You cannot get anything more than that. Whatever you index, whatever indices you choose, this is the maximum you can get here. Okay, so this is how they define the score, and this is what the problem is. So now you understood what the problem is, right? And why we are choosing 3, because k value is given to us as 3 here, right? So k is equal to 3, that is given to us. Okay, so with these examples you now understood what the problem is. So how can we solve this problem? So these numbers can appear in any order, we don't know, right? They may not be sorted also. So first thing what we will do here is we will have to create a pair objects here, right? Pair objects. So what the pair objects will do? Pair object is this. This is a pair basically. Pair of indices from both the arrays. This is one pair. From here, this is another pair, right? 14, 6. The other pair I can get is this 12 and 4. Other pair I can get is 10 and 12, right? This is one pair. So total 4 pairs, right? So this is pair 1, pair 2, pair 3 and pair 4. So I created 4 pairs, let's say, right? Pair object. So there are two things in this pair, right? Two things. So we'll call the first thing from the nums1 array as a sum. Let's call this 10 as a sum, right? Let's call this as a sum, and let's call this 2 as a min. Okay, min. Because we want to choose sum from the first array and we want to choose minimum from the second array. So let's call it sum and let's call it min from second array. Okay, so there are two things that pair has, right? So I'll create 4 pair objects here as I shown you, and then I am going to sort the pair objects, right? So how I will sort the pair objects? The pair objects will be sorted based on the sum in descending order. So this is how I'll get the sorted pair objects. That's what I wanted to show you here. So this is a screenshot that will show you how the pair objects are sorted. So first pair object is maximum sum that you can get is 16, right? So this is 16 first, then 14, then 12, and then 10, correct? So they are sorted based on the sum in descending order. This is clear, right? So this is very easy, right? You can just use array.sort method and sort the objects, which is pair objects. Pair objects has two things, 16 and 8, right? This is one pair object. Another is 14 and 6 is another pair object, right? Another is 12 and 4 is another pair object, right? Okay, and another is 10 and 2 is another pair object, right? So 4 pair objects, and they have we have sorted them now based on the sum in descending order. So until this point you are clear, right? So okay, now what we will do after sorting is we will add this pair objects also in the like we will also have to add the this minimum things that we are going to go. So now we will start looping through the sorted pair objects, and we will start going from sorted pair objects. So you will first visit this 16, right? Because this is the first one in sorted, right? Okay, second one you will get 14, third one you will get 12, correct? Because it is 16 is the first in sorted order, then 14, then 12, correct? Okay, at the same time you will keep adding the minimum values in a priority queue. Priority queue is a very important data structure. We are going to use it here as a min heap, right? So priority queue, right? Priority queue. So I'll show you the documentation, so don't worry about it. So priority queue is a min heap here. So what we are going to put in that priority queue here are the min values, right? So let's say this is our priority queue. So in the beginning nothing is there, and we are going to put these values 8, 6 and 4. So 4 will be on the front here because it's a min heap, and then 6 and 8. So what min heap does is it will always keep the minimum value on the front. Okay, always minimum value on the front. So if I remove a value from priority queue, I'll first get 4, then I'll get 6, I'll get 8, right, in that sequence. Okay, so these values are there. So now we have seen three values, right? So we have seen these three values for 16, 14 and 12. Now as soon as we see k values, we will find out our score, right? How you will find out score? 16 plus 14 plus 12, correct? So you will get the sum, so sum will be 42, correct? And you will take the minimum from all these values. So minimum, you can just pick this priority queue and you will get minimum from the priority queue. You are not removing it, okay? You are not removing it, you are only picking the priority queue. Picking means you are just looking what is on the front of that priority queue. So you will get 4, right? So you just get that 42 multiplied by 4, you will get 168. So this is your score, right? So you will say that this is my maximum score. You will store it somewhere, right? So 168 you stored it, okay, as a max score. So let's say you have one variable max and you stored 168 there, okay, 168. Now you still have some elements to process, right? So you will go to the next one, right? You will go to the next one. So this is 10 and it's this nums2 min value is 2, right? So you will check if this min value, now you will again want to, now you will add this 2 into the priority queue, correct? You add 2 into the priority queue, this value 2, correct? And then you realize that your priority queue is exceeding this value k, right? So now your priority queue has a 4 values, right? You can only have 3 as a subsequence values. You are allowed to choose 3 elements as a subsequence. You are choosing more than that, so you will remove the minimum value from priority queue. So minimum value you will get 2, right? Minimum value you will get 2, and you will again so you have removed this pair object from priority queue, right? Again you will calculate the, now you will again calculate the score, right? So when you are calculating the score, you will also make sure that your score will be, so your sum was 42 before, right? Until this point your sum was 42, correct? Because 16 plus 14 plus 12 is 42 was your sum. Now when you are seeing that 10 pair, it got increased by 10, right? So it became 52 at that time, right? But now you realize that now it is 4 elements, you are only allowed 3 elements, so you removed the minimum from priority queue, correct? So you removed this one from priority queue, so it means that you are going to decrease this sum again by 10, right? Because you don't want to consider it, basically you don't want to consider it, right? So it will again become 42. Again you will find out the minimum from this priority key, you will get 4, again you will multiply it, you will get 168 here, right? So it is, we are making sure that you will always get the maximum score. So if this is not contributing to your score more, then you will not consider it. But instead of this 2, if you had, let's say 10 here, for example, if you had 10, then you would have taken that 10 basically, correct? Because when you, so this one is very very important now. So I will remove some of the colors, so I'll explain you why this logic works, right? So that you completely understand this. So until this point it is clear to you, right? Okay, so here also we process this, our priority queue was having these elements, right? So you had 4, 6 and 80, right, in your priority queue, correct? Okay, and you already calculated that 168, that was your score, right, in the beginning. Now, right, let us assume that instead of this 2, your value here, instead of this 2, your value here is, let's say 10, correct? 10 is your value, right? Okay, now you started processing this element. Now for these 3 elements your sum was 42. So, agreed, right? 16 plus 14 plus 12 is 42. So you added this 10 into 42, so it became 52 now, right? See, your sum became 52. Now you actually are you added this 10 into this priority queue, so it went here, right? Because it will be last, its maximum value, right? Okay, you realize that your priority queue is having 4 elements, you are only allowed 3, right? So you will remove the smallest one from this priority queue, so you will get 4. So you will get this time you will get this element now, right? This is going out basically from priority queue, correct? How much is this sum? 12. So you are going to reduce this by 12, correct? So it will become 40. This is very very important, okay? 40, right? And at that time you will check what is the minimum number you have now. So 10, 6 and 8, the minimum number you have now in the priority queue, this you removed, so minimum is 6. So 40 multiplied by 6 you will calculate, right? So it means that it will give me 240, which is more than 168. So I will have to update this with 240 because this is giving me more score, correct? You got it, right? So this is why this logic works. Okay, clear? I hope it is I explained you clearly. So what we have done here is, we assume that instead of 2 you had 10, right? So this priority queue helps us identify, always it helps us identify which minimum value we should remove so that we can maximize our score, right? Which value we should remove so that we can maximize our score. So in this time you have removed 4 value because you want to maximize your score, correct? So I hope it is very very clear for you now. I explained you as much as I can with this diagram, examples, everything. So now we are going to go through the Java code and understand how to implement the same logic, right? So we created a static class. It has two fields, right? Sum and min. So sum is for the first array, min is for the second array, right? This is a very simple um, Java class, right? Now max score is what we are implementing. You have two arrays, nums1, nums2, and you also have the k value, right? This method returns long, which is the maximum possible score, correct? You will calculate the n, which is the size of the array, and you will create a pair array of size n, right? Because the same size, right? The array size and the pair array size should be same. You are going to go through the n elements. You are going to create an array of pairs from nums1 I and nums2 j, nums2 I, right? So this is the where we are creating pair objects, putting it into this pair array, right? So now your pair array is ready, so you have to sort this array. So you are sorting it based on the sum in descending order. This is where you are doing it. Arrays dot sort array, your lambda expression is a comma b, b minus sum minus a minus sum, b dot sum minus a dot sum. It means that you are sorting these pairs based on descending order of sum. So as you can see, this is a descending order of sums, 16, 14, 12, 10, right? Okay, so this is what you will get after you sorted it. Fine. Okay, after that we will create a priority queue. Priority queue is going to hold again pair objects, but this time it is going to hold pair objects based on the minimum value, right? In ascending order. This is very important. Minimum value in ascending order. So here we are creating it, right? We are providing the lambda expression to the priority queue in the constructor a comma b, a dot min minus b dot min. So this is a min heap, right? This is a min heap where the it is min, like we are choosing minimum between all the min values basically, right? Okay, so this is how you created a min heap of priority queue pair objects, right? So long is answer is 0 and sum is 0, right? So there are two variables we created, and now we start looping through the each pair object in this for loop, correct? We will add the pair object into the priority queue. We will find out the sum, right? So sum is equal to sum plus array I dot sum, right? And then we will check if our priority queue size is exceeding allowed k value, right? P dot size is greater than k. It means that it is time to remove the minimum min element from priority queue. So pq dot remove, you are removing the minimum element from priority queue. For example, if you have 4, 6, 8, 10 these pair objects, right? 4, min value 4, min value 6, min value 8, min value 10. When you remove it, you will get the minimum value 4 out from the priority queue. That's what you are doing it, right? pq.remove. Once you get that object, then you have actually removed it. So you are not considering that object now when you are calculating the sum. So you have to reduce your sum by that much sum, right? So sum becomes sum minus top dot sum. So whatever you removed here from priority queue, that much sum you have to reduce from the original sum, correct? Because you have removed it, correct? So this part is clear. Why we did that? Because our priority queue size is becoming more than k allowed value. So you have to remove something from it, right? Because let's say you are allowed three elements, because you are allowed three elements to choose. If you are choosing four elements, you obviously have to reduce one element so that it becomes three, right? So that's what we are doing here, correct? Okay, so you updated the sum. When your priority queue size is becoming k, right? One more time I'm repeating, when your priority queue size is becoming k, then you have to calculate your score, right? So sum multiplied by pq.pick.mean, right? And it will give you your sum, and you will it will give you your score, and you will update your answer with this score if it is more than your answer, right? Math.max between answer and result, right? So you will always keep track of the maximum score that you have seen during this process in the answer variable. At the end, you have to just return the answer. Okay. So exactly what I explained you here, this is the same thing, right? This is the same thing. Okay. So this is how you can implement this Java solution code. So pq.pick does not remove that element from priority queue. It only gives you the object, but it does not remove it, right? So we will run this code now and make sure it gives us correct answers. So for the first one, we are expecting 12 and we are getting 12, which is a correct answer, as you can see here. For the second one, we are expecting 30 and we are getting 30, which is a correct answer. Submit this code now to the Leetcode, make sure it gets accepted. And as you can see, the code is successfully accepted by the Leetcode. It is 94.94% faster on the performance side and 56.41% faster on the memory usage, which is a very good and fast solution to solve this very interesting coding problem on the Leetcode 2542 maximum subsequence score. So I hope you understood this logic clearly and you understood this Java solution code today. So I'm going to add this Java code for you in my GitHub repository, give you the link of my this code so you can check it out. There are lots of other important algorithms and Java solutions already implemented and available there for you in the GitHub repository. So don't forget to check it out. If you like the Java solutions in the GitHub repository, please consider giving it a star on the GitHub repository. That would be great. So before we so I wanted to quickly show you some priority queue documentation that we have used today in our coding. So this class is in java.util.priorityQueue. It uses generics, another very important Java collections framework class. This class got introduced in Java 5, right? And as you can see here, it is an unbounded priority queue based on a priority heap. The elements of the priority queue are ordered according to their natural ordering or by comparator provided at queue construction time, right? So you can use it as a min heap or max heap, right? And another important thing I wanted to show you are these last two lines, which are discussing what is the time complexity for some of its important methods. The four important methods are offer, poll, remove, and add. If you want to add something or remove something from the priority queue, which is enqueuing and dequeuing, it takes log of n time, right? So it's a logarithmic on time, right? If you are using a remove object or contains object method of priority queue, it takes linear time, which is order of n. And if you are using pick element or size method from priority queue for retrieval, it takes a constant time, right? So this is something you should know. And these are the overloaded constructors of priority queue class, and these are couple of methods that you should know is add method, offer method. These methods are useful to add something into the priority queue. The pick method and poll method will give you the head of the priority queue. The difference between pick and poll method is that the poll method also removes the head from the queue. Correct? It will also remove the head from the queue, right? So this is what the so go through all this documentation. This is very important class of Java collections framework, and very handy and useful class to solve these kind of problems in a clean way, right? So so I will add this code. I'll give you the link of my GitHub repository. If you are new to this channel, there is a very important coding interview related playlist we have created to help your interview rounds. It is called as Leetcode and Leetcode solutions. 200 most frequently asked very important coding interview problems are compiled for you under that one playlist. Those problems are asked by Google, Facebook, Amazon, Apple, Microsoft, Yahoo, Uber, Lyft many times in their past interviews. They are very important coding interview problems. Make sure you go through all of them, understand them thoroughly. If you go through all those videos and problems, you are going to learn a lot about data structures, algorithms, problem solving, logic building, Java programming and coding. It will also help you learn lots of new techniques, lots of new ways of problem solving. So do check out the solve coding problems. The name of the playlist is Leetcode and Leetcode solutions. Now, if you are a fresher, junior level developer and you want to solve more coding problems and practice more coding problems, to help your practicing purpose, we have created 3 other playlists for you on this channel. The names of those playlists are Code Forces, Code Chef at Coder, Code Forces, Code Chef at Coder. All in all, more than 800 different varieties of problems are here to help your interview preparation and learning different computer science concepts. If you like this Java solution, how we have used this priority queue and sorting and this pair objects class to solve this important array coding problem on Leetcode 2542 maximum subsequence core, then please give it a thumbs up to the video, give it a like to the video, subscribe to this channel. Subscription is very important because that's how the videos can reach to other people, so others people will also be able to watch and learn from these videos. So do subscribe to this channel, share this video with all your colleagues and friends, so they will also learn how to solve these kind of problems and how to implement their solutions in Java. Click on the bell notification icon button right away so you won't miss any important postings from this channel. On this channel, you will find lots of solved coding problems explained with Java code that includes graphs, matrices, binary search trees, breadth first search, depth first search, cadence algorithm, binary search algorithm, Kruskal's algorithm, Dijkstra algorithm, sliding window algorithm. There are also lots of important data structure questions available for you here, including stacks, queues, priority queues, hash table, hash map, tree set, hash set, linked hash map, linked hash set, arrays, linked list. All of them are important problems from interview perspective. Go through them, understand them well. Every problem is given with your Java solution, so that you can go to the GitHub repository, check out the code, play with the code by creating your own custom input test cases for your clear and easier understanding of all those solutions. If you are a fresher, junior level developer planning to take Java interviews, there are lots of Java related videos available for you on this channel. That includes, for example, frequently asked Java telephonic interview questions and how to answer them, Java design patterns, Java architecture, SQL programming questions to the freshers, where they will give you database tables, they will ask you to write SQL queries, where you may have to use different database concepts like inner join, outer join, aggregate operations, group by and having clauses, different where clause conditions. Everything is explained in those videos with database tables, data as well as SQL queries. There are videos that discusses recently asked questions to the freshers about Unix, like Unix scripting questions, Unix commands, Unix utilities questions. All are here to help you in your interview preparation and learning process. If you like the videos on this channel, if they are helping your learning process, you are learning new techniques, more problem solving along with Java programming and coding, then please do leave your messages, your feedback, your comments below these videos. Your messages, your feedback, your comments are highly appreciated, very important and valuable for us. They increase our motivation to create more quality content videos. So do leave your messages below these videos. Tell us how the videos are useful and helpful for you in your learning purpose. Click on the bell notification icon button right away, and share these videos with all your friends. If you want us to create videos about any specific computer science, Java J2E or interview related topics, then please mention those topics in the comment section below this video so that we can create those videos for you here. Keep learning, keep coding, keep solving more varieties of coding problems, and most importantly, keep your learning process and practicing going on continuously. And thanks for watching these videos.